Have you ever wondered if time could behave like a disobedient child, refusing to stick to its steady tick-tock rhythm? Well, let's embark on a journey that will make you question the very fabric of reality as you know it. In the grand cosmic theater, where stars pirouette in the endless waltz of gravity, we find the two protagonists of our story, time and space. They are not mere spectators, but active players in this cosmic ballet. Let's take a moment to consider time. We perceive it as a constant, unyielding force. Every second ticks away, unchanging, whether we're sipping coffee at our desk or skydiving from the edge of space. But what if I told you that this isn't necessarily the case in the world of physics? Time is a bit of a rebel. It doesn't always follow the rules we lay down for it. Instead, it dances to its own tune, a rhythm dictated by speed and gravity. This is known as time dilation, a key concept in Einstein's theory of relativity. Now let's turn our attention to space. It's not just an empty stage for matter to exist in, it's an active participant, bending and warping under the influence of mass and energy. This bending of space, or space-time as it's often referred to, is another crucial element in our understanding of the universe. Now imagine, if you will, a pair of twins. One decides to embark on a journey to the stars, traveling at speeds close to light. The other stays on Earth. According to the rules of relativity, time would pass differently for each of them. This is the crux of a thought experiment known as the twin paradox. Intriguing, isn't it? Dare to venture into the realm of the twin paradox? Imagine two twins, one embarks on a high-speed journey through space while the other stays on Earth. Who ages faster? The answer might surprise you. Now let's dive into the heart of the matter, the twin paradox. This paradox is a thought experiment, a playful dance of physics and philosophy that takes us deep into the ideas of time and space. At its core, the twin paradox is a phenomenon connected to the theory of relativity, proposed by Albert Einstein over a century ago. This theory, among other things, tells us that time is not absolute, but relative. It can stretch and squeeze like a piece of elastic depending on how fast you're moving or how strong the gravitational field around you is. This is known as time dilation. Now let's get back to our twins. Suppose one of them, let's call him Alex, decides to go on an adventure, boarding a super-fast spaceship that whizzes him around the universe at near-light speeds. His twin brother Ben decides to stay on Earth. As Alex zooms through space, time for him starts to dilate, to stretch out. For every minute that passes for him on his spaceship, more than a minute passes for Ben back on Earth. This is because, according to relativity, time runs slower for objects moving at high speeds. So, while Alex is enjoying his cosmic jaunt, Ben is experiencing time at its regular pace back home. After a few years of travel, Alex decides to return to Earth. He expects to find Ben a few years older, just as he himself has aged. But to his surprise, he finds that Ben has aged more, much more. He has gray hair, wrinkles, the whole 9 yards, while Alex has barely aged. This is the twin paradox, the strange and counterintuitive prediction of Einstein's theory of relativity. It tells us that time is not the same for everyone, that it can be molded and shaped by speed and gravity. So, our space-traveling twin returns to find his earthbound twin has aged more. That's the twin paradox in its simplest form. Now, you might ask, why does this happen? Well, let's dive into the key points of the twin paradox to understand its intriguing intricacies. The crux of the paradox lies in the concept of time dilation, a core principle of Einstein's theory of relativity. Time dilation essentially means that time can stretch or squeeze based on the observer's velocity and gravitational field. In the context of the twin paradox, one twin travels near the speed of light while the other remains on Earth. The traveling twin experiences time slower than the twin on Earth, leading to a difference in their ages upon return. This might sound like a plot straight out of a sci-fi movie, but it has profound implications in theoretical physics. The twin paradox is not merely a perplexing puzzle, it is a testament to the elasticity of time and space. It illustrates how the universe doesn't adhere to the rigid, unchanging flow of time that we experience in our daily lives. The effects of velocity and gravity on time also have significant implications. The faster one moves through space, the slower they move through time. Similarly, the stronger the gravitational field one is in, the slower their time ticks. These effects, while negligible in our day-to-day lives, become pronounced when dealing with astronomical distances and speeds, or in the vicinity of massive objects like black holes. Moreover, the twin paradox also underscores the importance of the observer's frame of reference in understanding the universe. It shows that time and space are not absolute constructs but rather relative to each observer's perspective. This relativity fundamentally transforms our comprehension of the universe's fabric. The twin paradox, therefore, isn't just a thought experiment, it's a doorway into understanding the flexible nature of time and space. It provides a tangible example of how relativity shapes our universe, challenging our conventional understanding of time and space, and prompting us to view the cosmos through a different lens. Still with me? Good. The twin paradox might seem like a concept ripped straight from a sci-fi novel, but it's grounded in reality. We've unpacked a lot today, from the elasticity of time to the peculiarities of relative motion. It's a lot to wrap your head around, right? But that's the beauty of theoretical physics. It challenges us to see the world and the universe in new and exciting ways. The twin paradox isn't just a thought experiment, it's a testament to the boundless possibilities that this universe holds. It invites us to question our understanding of time and space, pushing the boundaries of what we perceive as reality. So I encourage you to dive deeper to explore more about this fascinating world where reality often seems stranger than fiction. And who knows, you might just uncover more paradoxes waiting to be unraveled. So, the next time you gaze up at the stars, remember, the universe isn't just vast in space, but in time as well. Until our next cosmic journey, stay curious. Please subscribe, like, comment, and share my YouTube channel if you are interested to see more videos like these. Thanks for watching.